Okay, well, good afternoon, everybody. You're very welcome to this Institute of Refrigeration Ireland webinar. My name is Declan Fitzmaurice. I chair the Technical Committee on the Council. And this is one in a series of webinars we're presenting over the summer to support the industry in meeting this public inquiry process for the proposed revision to European standard EN378. And as always, thank you to all our members. We have 300 or so members and maybe I think 58 or something corporate partners. And we're very grateful to them. It means we can provide the services and supports that we do to the industry. And we're very grateful. And part of the webinar series is we asked all our corporate partners if they had any training programs related to EN378 that we could include as part of the series this summer, and several responded positively. We've had one already. We have one today from Frigobon, and I think we've one next week from RSL. So it is a big day today. Coincidentally, this is the day that the draft inquiry document is due to be published. I haven't seen it come out in the emails just yet, but it's due to come out today, the 3rd of July. So all across Europe, the national standards bodies will receive their copies, and they'll have their own process to follow to upload the standard, the draft inquiry standard to their own website. And in Ireland, it's the National Standards Authority of Ireland. There's a link on the screen. And if you just go to the NSIA website, you'll be able to find a link to have your say, your standards, your say, and just to register. There's no charge. And you say what standard you want to participate in, and then they will forward you a copy of the draft. So I'm looking forward to seeing that this afternoon. And we will have Jonathan Quigley from the NSAI in about a month's time, on the 21st of August. So kind of halfway through the inquiry stage, and he will tell us how to participate. So last week we had a nice webinar from the Norwegian Society with Espen running, and also we had the release of the IRI information bulletin. This week, I'll be very happy to hand over to Shazier Dixon of Frigobon. And Shazier will be talking about transitioning over to A2L refrigerants and the responsibilities that go with that, how to calculate the charge limits, and what the regulatory and safety requirements are according to EN378. And Shazier has been a great supporter of the Institute, and we're delighted she's here today. I've seen the presentation and it's fantastic. So over to you, Shazier.
Thank you. Thank you very much, Declan. And thank you very much, everybody, for joining us during your valuable lunchtime. I'll start sharing my screen. And yes, like Declan was saying, so we are being asked saying if we had anything in available that we could share. And this is basically the presentation that my colleague, our refrigeration manager, Guillaume Munier, he put this presentation together a couple of years ago. This is the current version, and I will take you through. I will try to obviously fit in what we have, and obviously this it was for internal purposes, but it will give good summary of the EN378 2016, which is the current version that we have it today. So if I just start sharing my screen, can you all see my screen now? Not yet.
Not yet.
Not yet. Okay, share. Okay, and slideshow from. Okay. Now you should be able to see my screen, yeah?
Yes, that's it. Thank you.
It's there. Okay. So I put my timer on, so we respect everybody's time. So yes, this is EN378 2016, which is the current version of the refrigerating systems and heat pumps, safety and environmental requirements. So just a quick introduction. So what we will just have a look at the why we are transitioning to A2L fluids and definitions of key definitions that we will be using. And what is the duties of the installers, and we are also going to touch up the procedures for maximum refrigerant load calculations, and we will also look at the regulatory requirements and safety measures. Just a kind of a disclaimer. So all the principles and technical points mentioned in this technical document are from EN378 2016, 2017, because we downloaded from our Spanish website, and not dealt within this guide, whose application is not sufficient to guarantee. So we're just attending this session, it's not guaranteed compliance with the standard or with any other regulation. So the aim of this document is to explain the key lines of the standard and its impact on the heat exchangers in particular. And this guide does not address the calculation regarding the toxicity. So today's session will be mostly focused on the A2L refrigerants. So why we are transitioning? So as of March 2024, the updated F-gas regulation has officially came into effect. So as you know, you can see from this, from this chart here, this was the previous regulation, which is showing you the phase down process. This is shown up to 2030, but it will go up to 2050. And the latest regulation that came in March is showing you the lower line. You can see the significant faster phase down of 24%, 27, 51, and 76%. So as we are going through, the availability of HFC refrigerants with high GWP refrigerant values will become scarce. And obviously, when something becomes scarce, also the cost likely to go up. So as a response, we need to start moving to low GWP refrigerants. So here is some of them are listed. But however, obviously, with these low GWP refrigerants, there's issues of the flammability and toxicity also comes into effect. So those are shown in green are non-flammable and not toxic. So A2L group here, they're mildly flammable. So we can see is R32, 454C, 55A, 1234, ZE, and YF. These are mildly flammable, and these are below 150 GWP refrigerants that we need to start getting used to it. And we just need to understand what is the implications of using these type of mildly flammable refrigerants on projects. So this is just a quick overview what EN378 consists of. So there are 4 parts. So part 1 is basic requirements, definitions, and classification. Basically, it's all the sales engineers, design engineer, project managers should really look at the part 1. And part 2 is looks at the design, construction, testing, marking, and documentation. It's primarily dedicated to designers, project managers, and manufacturers. And then part 3, installation site and personal protection, is primarily directed to project leaders, supervisor, refrigeration, and technicians. And then part 4 is for operation, maintenance, repair, and recovery, and primarily directed to refrigeration technicians, operation managers, and maintenance personnel. So if we just look at the key definitions that we will be using throughout this document. So when we say unit system, this is a self-contained system that has been assembled, filled, and ready to use and tested priority installation, and which is installed without the need to connect elements containing refrigerants. So this will be like a monoblock system. And the sealed system is a refrigerant system in which all refrigerant-containing components are made tight by welding, brazing, or similar permanent connections, like cap valves, cap service ports, permitting proper repair or disposal, and having a leakage rate determined by a test of less than 3 grams per year at a pressure of at least 1/4 of the maximum allowed pressure. Refrigerating installation, assembly of components of refrigerating system, and all the apparatus necessary for its operation, and refrigerating equipment, component forming part of the refrigeration system, such as compressor, condenser, generator, and so on. And occupied space in a building that is bounded by walls, floors, and ceilings, and that is occupied by people for a significant amount of time. And ventilated enclosure containing refrigeration system, which does not permit the circulation of air from the enclosure to the surrounding space, and which is provided with ventilation system, which produces airflow of air from the enclosure to the open air through ventilation duct. So what is the duties of installers? So EN378 standard requires a risk analysis to be carried out to reduce the possible hazards of refrigeration systems and refrigerants to the people, property, and environment. So there are 3 key actions the installer must follow in order to comply. First, to define the maximum allowable refrigerant charge for the system. This ensures that in the event of a leak, the concentration of refrigerant remains below hazardous levels. Based on this, appropriate safety measures such as ventilation or leak detectors must be put in place. And the second, they need to follow the supplier's requirements. This means reading and applying the recommendation and in the installation and operation and maintenance manuals, as well as obtaining all the safety notices that are provided with the equipment. And the third, installers must take into account and all the local and national regulations that apply to the installation. So this is the just wrapping up the section 1. So the procedure for maximum refrigerant load calculation. So these are the steps that we need to follow. So it is listed in Annex C. So access categories, and we need to decide on the location classification, system classification, type of refrigerant we are going to use, and then we need to calculate the refrigerant quantity limits for the space that we are designing for. So for the access categories, so there are three types. So A is the general access. These are the buildings and rooms where uncontrolled number of people are present and anyone has access without being aware of the necessary security measures. So that will be like a hospital environment, supermarkets and restaurant, etc. And B is the supervised access spaces. These are the spaces where only limited number of people can gather, and some of them will be aware of the necessary security measures are on site. So for example, like laboratories or manufacturing sites. And C is the authorized access. These are the spaces, only authorized people will enter the spaces and they will be aware of the necessary security measures on site. So for example, production premises of like dairies, slaughterhouses, cold stores, and other which are not accessible to the public. So in terms of location, there are 4 categories that we need to be aware of. So class 1 this is where we have the mechanical equipment located within the occupied space. So if the refrigerant system is located inside the occupied space, will be classed as class 1. And class 2 is the compressor in machine room or needs to be in the open air. If all compressors and pressure vessels are located inside the machine room or in the open air. And machine room or open air, if all parts of the container refrigerant are located inside the machine room or in open air, and ventilated enclosure, if all parts containing refrigerant are located inside a ventilated enclosure. And then we need to decide whether our system classifications, so whether it's a direct system or an indirect system. So direct system here will be when all the refrigerant is in the contact with the air or the product is to be cooled cooled or heated. So this is the occupied space. There will be our evaporator and the refrigerant containing parts. So we have the refrigerants in contact with the air or the products. And the other system is indirect system which in a secondary heat transfer fluid in a closed circuit is in the contact with the air or the product to be cooled. So we will have potentially the brine cooler will be in the space, and there will be A2L chiller will be in the outside space. And Annex E gives us the document. It's quite a big long table, but we have all the values in this table. And it lists all the refrigerant numbers and all the key properties that is required for us to be able to calculate the refrigerant charge. So here we have the summary version. So we have the safety class. So these are all A2L refrigerants. That means they are mildly flammable, non-toxic refrigerants. And it gives us the LFL numbers, so lower flammability limit in per kilogram per cubic meter. And then it gives the QLMV. This is the quantity limit with minimum ventilation. And then this is the quantity limit with additional ventilation, and also GWP. So we will need these numbers to be able to calculate it manually. Here's an example. So for example, if you look at a unit cooler, that will be installed in a space of 50 cubic meter and connected to a condensing unit in an engine room. So these are we have selected, for example, from the previous category. So it's a direct system because the unit cooler is in the cold room. And class 2, because all compressors are located inside the machine room or in the open air. And we have supervised access because only supermarket employees have access to the cold room. We have selected refrigerant 1234YF, which is an A2L mildly flammable refrigerant, and C3 conditions because all the conditions have been validated. And here are the key parameters that are for the R1234YF. So there are several formulas that we can adopt. However, today is a number of companies already have online calculation tools. So you will be able to calculate and do a quick selection to verify whether your room has got the correct charge or not. But you can have access to these online. This is just a manual version of it. So first of all, if it's a sealed system, so yes, so we can use the formula because X equals 4 times 1.5 times LFL. So the value of 4 and 1.5 and LFL and 1.5 is given in the EN378, and LFL will be based on the source from the refrigerant that we select. And in this example, we will get a room charge of 1.734 kilogram of charge limit in a seal system. And if it's we calculated according to table C2, so each of these tables got the number of requirements and the categories that you need to be able to match. So once you have this table C2 categories, then you have the formula of 20% times LFL. Again, you get the number from here and the room value in cubic meter. So if we use this formula, and has to be the result has to be not more than 25 kilogram. So in this calculation, we are getting 2.89 kilogram, which is less than 25 kilogram. And when we compare to these two values, we can take the highest value. So since 2.89 is the highest value from both criteria, so we can take this 2.89 kilogram room charge for this example. So if we complying all the, if we have provided all the, if we met all the criteria for the previous parts, C2 and table C2, and then we can also move on to higher refrigerant load category. So we can have a look, use these formulas. So we have the quantity less than or equal than room size times the quantity limit with minimum ventilation. And the other one is quantity either less than or equal to room value times quantity limit with additional ventilation, and the quantity less than or equal to M3. M3 is one of the categories, these kind of steps that EN378 provides, and this value is fixed here, 130 cubic meter, and then times 1.5. So this is already given in the EN378. So if we use these formulas, so for this same room, we will be able to get 3 kilograms of refrigerant we will be able to use. And in this aspect, we will not need any safety measures for this installation. For the second example here, so second calculation, 7 kilogram. In this one, we have to have at least one safety measure in the room. And in the highest category here, 56.4 kilogram, we will have to have the minimum of 2 safety measures in the room that we will be designing. So if we plot this onto a chart, so here we can see on the vertical axis, the refrigerant quantity and the cold room size here in cubic meters. So we are in anything that we have plotted here falls into case here, then we will not need any safety measures. However, it's highly recommended that to implement at least one safety measure is a good engineering practice. In the plot area 2, in this area, all C3 conditions must be filled, and at least one safety measure must be installed in accordance with this standard. And plot area 3, in this area, again, the requirements are more stringent, and all C3 conditions must be fulfilled, and minimum of 2 safety measures must be implemented for this room. And if you look at the same formula with the other refrigerants, this is R454C and R55A, and the key point here is basically, depending on the refrigerant that you are using, you will be able to use higher volumes in the space. Here, if you look at the R454C, you see after here, just under 12 kilogram, then you have to go into category 2. Whereas in the R55A, in the 200, you are going above nearly 17 kilograms of refrigerant that you'll be able to put. So this is the kind of so we decide which refrigerant to use, and obviously depending on the application, then this is the kind of things that we need to bear in mind. So this is the end of the second section. So if we just look at quickly the regulatory requirements and safety measures. So there is in the standard there's a section called generalities, and this section applies only to systems that use refrigerants classified as A1 or A2L. A1 refrigerants are non-toxic and non-flammable, and A2L are mildly flammable. Even with these low-risk classifications, precautions are still required in case of leakage. So when installing indoor unit below a ceiling height of 1.18 meters, special attention must be given to potential refrigerant leaks, as because the leak refrigerant is heavier than the air, and it can accumulate near the floor and create suffocation risk if not properly dispersed. To address this, one or more of the following devices must be installed, such as an indoor unit fan, circulating pump, and mechanical ventilation device. And these must be always running or automatically triggered by a gas detector in case of a leak. And so the goal is to avoid stagnation of refrigerant gas, which can endanger occupants in the space. And so this is the marking and the documentation. So this section outlines the key marking and documentation requirements for refrigeration systems using flammable refrigerants, particularly A2L. First, the service points. So we need to be service access points must display the flame symbol, like this one is which will be according to EN ISO 7010 W021 to warn about flammability. And secondly, the identification plate on the system must include essential information such as manufacturer's details, model serial number, year of manufacture, refrigerant type and charge, and maximum allowable pressure. And for flammable refrigerants, like flame symbol is mandatory to include in the label at a minimum of height of 30 millimeter, and that color isn't required. And these markings to ensure that safe handling, servicing, and regulatory compliance of the equipment. So on site, this section outlines the critical documentation that must be readily available at the installation site of any refrigeration system. So the goal is here to ensure the safety and transparency and rapid response in case of emergencies. First, installer must provide key contact details. So this includes their own name, address, phone number, along with those of their service department. And also required are the contact details of the operator's service department, plus emergency numbers such as fire department, police, local hospital, and ideally burn center. This ensures that anyone on site knows exactly who to call in the case of emergency. Next, the documentation must clearly state the nature of the refrigerant used in the system so that responders, when they attend the site, and technicians understand the specific hazards involved. And there should be a clear instruction for how to shut down the system in terms of emergency. And this is vital for minimizing harm and protecting both people and the environment. And the documentation must include maximum allowable pressure or MAP, which ensure the system is not overpressurized beyond its design limits. And finally, it must outline the flammability characteristics of the refrigerant. So this is crucial, especially when working with A2L or A3 refrigerants, where flammability is a risk are a lot higher. Altogether, this is an on-site information, acts obviously to protect both safety and also quick reference guide for emergency and for maintenance situations. So this is protection against fire risk. So again, this section focuses on protection against fire. So the key principle here is to ensure that any leakage of refrigerant does not lead to a fire hazard, particularly in areas where equipment or components could ignite a fire. So refrigerant leaks must not spread or stagnate in places where ignition sources are present. To reduce the risk, components and apparatus are only considered safe, meaning that they won't ignite a fire. So if they meet at least one of these conditions, then they need to be able to, then we can do this. So positioning, so components are placed outside the potentially flammable area where leaked refrigerant might accumulate. And the ventilation, components are ventilated with high enough airflow, either continuously or before activation. And this ventilation ensures that refrigerant concentration near the equipment stays below 50% of the lower flammable limit, which minimizes the risk of ignition. Or the use of ATEX compatibility. Equipment is certified for hazardous zones according to EN378 A2L 10-1. This means the equipment is designed to be safe in potentially explosive atmospheres, and electrical safety for electrical devices. Any spark or arc generated within their circuit cannot ignite refrigerant. It cannot ignite the refrigerant even at the highest flammable concentration. These measures collectively help prevent fires, safeguarding personnel and property while ensuring the compliance with the safety standards. And the mechanical ventilation. So mechanical ventilation must either run continuously or be activated by a sensor. So this helps maintain the consistent airflow. And we also need to have the safety shutoff valves. In the event of a leak, these valves must quickly stop the flow of the refrigerant to ensure that the total leaked quantity remains below the quantity limit additional ventilation threshold. And the calculation for this leak quantity, we can use this formula. So Q is the ventilation airflow rate in cubic meter per hour. And then 10 is the maximum expected leakage rate in kilogram per hour. And then RCL is the refrigerant concentration limit in kilogram per cubic meter, according to ISO 817. And we also need to use we can also use the safety alarms. So the alarm system shall generate both an audible and visual warning, such as loud buzzer. So it needs to be able to generate a noise of 15 decibel in the space. So this above the ambient sound level, and the flashing light. And important, alarm system power must not be sourced from the refrigeration systems and mechanical ventilation. Battery-powered emergency electrical system may be used for to power the alarm. And the location of the detectors. So this section covers the location and sensitivity requirements for refrigerant detectors as the standards. So the location of detectors must be chosen according to refrigerant, and they must be located where the refrigerant from the leak is concentrated. So at least one detector shall be installed in engine room or occupied space, in the lowest room for heavier than air fluids, and in the highest room for the lighter than air fluids. And the refrigerant detectors, an A2L refrigerant detector shall activate the alarm signal at a level not exceeding the 25% of the refrigerant lower flammability limit. And the sensitivity tolerance of the detector must be considered to ensure the tripping at a level less than or equal than 25% of the LFL limit as well. So this concludes the technical session. Just to give you a quick overview. So we are Frigabone, and like I said at the beginning, we do not endorse any particular refrigerant usage in the market. Our systems are A2L compliant since 2021. So we have a A2L and A1 compliant condensing units up to 30 kilowatt. And this will be matched up with our evaporators. Again, they are multi-fuel, or they could be connected to display cabinets in supermarkets or in restaurants. We also have a CO2 complete system. So we have the CO2 transcritical racks. And again, we have a CO2 evaporators, and we also have the gas coolers. Again, we are in a position to be able to offer a total CO2 package as well as a manufacturer. And if anybody has any questions and would like to get in touch, then these are my details. I'm based in the UK, and this is my mobile, and this is my email address. So you're welcome to get in touch with me. And that finishes our presentation.
That's fantastic. Well, thank you, Shazia. That was an excellent presentation. Perfect use of the time. Now it's taken us right up to 1:45, so we won't have time for Q&A, but I expect if anybody has any questions, feel free to get in touch with Shazier directly. Her email address is on the previous slide, and that will be saved on the recording, which will be uploaded to our website. So it just remains for me to inform you of the webinar next Thursday, which will cover ammonia. Up to now, we've covered primarily A3 and A2L refrigerants. The A2Ls, Shazier was speaking about, are refrigerants like R32, which are low in toxicity. The lowest toxicity level, but they have some degree of flammability. Ammonia is a B2L refrigerant, so it has similarly moderate flammability under the ISO classification system, but it also has the added hazard of toxicity. But it's very popular. We think there may be between 300 and 500 ammonia sites in Ireland. And one of its biggest fans on the island is Seamus Carr, who's a former president of the Institute of Refrigeration. So Seamus will be giving a presentation next week on the selection of design and test pressures under the EN378 requirements, and also with mention of some key requirements for ammonia, such as plant room ventilation and so on. So thank you very much, everybody, and tune in at 1:15 next Thursday, and you'll be able to hear Seamus. So thank you, Shazier, again. Thank you all for attending.
Thank you very much.
Have a good day.